Good morning, students. Relation between current I and drift velocity V. This is important for 3 marks. This is important for 3 marks derivation, and almost every year they will ask you. They generally don't ask like this. They will ask. They will give the equation I equal to NAVD derivation. They will ask. Derive this expression. Consider a conductor of length L, area of cross section A with current I. Current is produced means we apply the potential difference V across the conductor. Drawing the diagram is not compulsory for this derivation, but if you draw, it's comfortable for you, but not compulsory. Figure is not compulsory. For some derivation, figure compulsory, but for this derivation, figure is not compulsory. Next, V is the potential difference across the conductor. So electrical is produced as a conductor, E equal to V by L. That is electrical. Mentioning this is actually not required for us, but let mention it required because we are going to use this again for the next derivation. So this part, this is not compulsory. Okay, you can simply take a current and you can jump directly to this N terms. These two, I mentioned it to explain that electrical produce which produce the force and produce the acceleration of the electrons, and the equivalent the atoms produce the having the drift velocity. Okay, and we can skip these two lines, of course. And if you write also, N is the total number of electrons in a conductor. These are producing current for us. That is flowing in time t. That time t we mentioned here. That means N number of electrons are passing per second. Or in the time t across this conductor of length L. Then velocity formula, what you have drift velocity, two formulas. Macroscopic level, if you take drift velocity is nothing but equal to displacement by time, L by t. Microscopic level, if you have taken means minus EE by m into tau we have taken. Tau is the relaxation time. This term is not required for this derivation, we take only macroscopic level. This part is enough for us. So t is the time taken by the electrons to cross the conductor of length L. Already we mentioned that. So drift velocity becomes equal to L by t. That's the drift velocity. It's a macroscopic formula. And area and length itself is nothing but equal to volume of the conductor. Then this point is important for you. Here number of electrons per unit volume. It's called the free electron density. Different names are there for this. Free electron density and number of electrons per unit volume means total number of free electrons. Free electrons means electrons that can pass from one atom to other atom easily in the conductor is the free electrons. Insulator's free electron density is less than negligible to 0 sometimes. So N equal to N by AL. Number of electrons by volume of the conductor is nothing but equal to free electron density. So writing this, if you are writing, this one is not compulsory required. Directly you can mention A to length itself, this volume is understood me. You can skip the point. So you must mention compulsorily this one, T, VD, and this one. This is not required. Okay, equations. When you are writing this, number of steps can be reduced once. So, but first sentence you write it and then you go for this small and compulsory you must mention, and VD also required. Or else VD later also we can mention. Then when current is passing, total charge that is passing through the conductor is nothing but equal to NAT, that is flowing energy. That is flowing. In time t only we mention. Current I is nothing but equal to charge by time is basic relation for the current equal to Q by T. Q is nothing but equal to number of electrons. Previously for number Q equal to small n we have taken, but here you have to be careful. Small n is different from capital for this case. Capital is the number of electrons, how many electrons are passing is that one in time t. Whereas small n is in the volume, that is constant. For any given conductor, this number of electrons per unit volume remains constant. Iron constant. Silver maximum n values. Silver is different n for the whatever volume is given. That means putting more volume automatically. More volume you are taking means the small n is constant, so number of electrons also increases. So if you take the silver, some number of electrons are available. If I take the double size of the silver, volume increases. Volume increase means you can increase area, length, whatever it is. That means number of atoms increases. When the volume increases, number of electrons also proportionally increases. Okay, but silver has a maximum small n value for the given volumes compared to that of other materials. So this I equal to NE by T. You will get this N substitution you have to take from this relationship. Capital number of electrons equal to the free electron density into volume. So N into A into L into E. N substitution I have taken here this part into E by T. But L by T already we have taken that as a drift velocity. So L by T is VD. I'll write as NAE into VD is the expression for the current I in terms of drift velocity. Okay, up to this you have the diagram not compulsory, but steps please check on that. Minimum steps only also you can take. Next point is derivation of Ohm's law. Derivation of Ohm's law is a microscopic form, or in terms of free electron density. Yeah, they don't ask it generally, but very rarely ask it. Till now, not asking this relationship. But relation is important. Final result of this derivation is important for us. We have to know this relationship height in terms of V. From there only we can at least start. Consider a conductor. Consider a conductor of length L, area of cross section A with the current I. Same point as before, but now that electric field and potential difference are required. V equal to potential difference and electric field E equal to V by M is electric field. It is produced inside the conductor by the potential difference. And Vd, drift velocity. Previously we had taken the macroscopic quantum, now we are going to take the microscopic relation. Vd is nothing but equal to minus Ee by M into tau. I am putting the magnitude. This is drift velocity. Magnitudes means minus, and I am not taking just take the drift velocity magnitude. Minus only indicates what the velocity is opposite to the electric. And what is this tau? Tau is relaxation time. What is the relaxation time? It is the time interval between two successive collisions. Between two successive collisions of electron with atom. And E is charge of electron. Magnitude I did put minus means magnitude of charge of electron. It may not be written as magnitude, you have to understand that. M means mass of electron. Relation between the current and drift velocity. I equal to N AT V. N extra where N is equals to free electron density of where small n is free electron density. I equal to Na. So take the relation I is equals to N into A into Vd. Vd you have to take the magnitude of the drift velocity, that is minus Ee by M into tau. Even if you take minus n, then you have to take minus also minus plus current result you will get is higher, positive direction of condition current. The result you will get is I is equals to Na into E square by M into tau into E, electric field. Electric field is V by M. This is tau into V by M. That the expression comes to V equation. So V is equals to V equal to I into cross multiply V equal to I into ml by n e square tau into a. I just separated the physical dimensions, length and area. N e square tau are constants. I get this as V equal to I. So V is equals to I into R. This is nothing but ohms. Where R is equals to remaining part. After I remaining part, this is nothing but equal to R ml m by n e square tau into L by A. So this relation you have to remember. Microscopic formula of the resistance. Macro V equal to IR formula generally takes only current this much path, this is a potential difference applied, resistance is this much you are getting. But your resistance is produced because of what? Collision of the electrons with the vibrating atoms. Then how that related is? That related for the given conductor is in terms of this relation. L is the length, more resistance. Okay, this relation already had in R equal to rho into L by direct relation we have taken, that is a exponential relationship. But this one is a derivation, theoretical derivation, microscopic relation. Microscopic means what is actually happening inside, what can affect the resistance inside the material. So length, physical dimension, this we can see, macroscopic. Length and area person we can see. What we don't see is inside. Mass of the electron is constant. Charge of the electron is constant. Tau is a time interval to the collisions of the electron with the atoms. Constant if the temperature is constant only. Temperature is constant, the atom distance is also constant. If the temperature increases, atoms vibrate, the distance with the atoms decreases effectively. So collision with the electrons also increases. Collision of the electrons increases means what? Time interval decreases. When time interval decreases, resistance increases. Next, the N relation. Number of free electrons availability. So N, if it is more, automatic resistance is less. So material with a high number of free electrons availability is, that means outermost orbit of free electrons availability is important for us. It's like the silver. Silver is the best conductor of electricity. It has a very high number of N. High number of N means less the resistance. Positive for physical length fixed. L and A should be fixed. But I can change the L and A. This is constant if I take also. I can change the L and A and we can change the resistance. More length, more resistance. So we can take this as therefore R is proportional to L and inversely proportional to A. Remaining all are constants terms. This is an expression you need to remember for the resistance in the microscopic form. And if we equate this m, n, e, tau constants again for the given material. So that is depends on the nature of the material we call and also temperature. So that R equal to rho into L by A. You will get the expression for resistivity from that. Next, third point. Only ohms law is up to that only, but you will be asked to find out the expression for the resistivity and conductivity also in terms of small n. Then you have to take the extra steps. Ohms law only, macroscopic formula in terms of n is up to this only. They don't ask anything, they don't ask for, but in case you must be prepared up to this issue. Next is they will ask for the resistivity and conductivity. So two more steps. R is equal to rho into L by A. Okay, right, this is R. Or R equal to rho into L by A, where comparing that equation where rho is equals to m by n into e square tau is resistivity. Here resistance depends on what factors, resistivity depends on what factors. One more question. We have two more questions. Okay. Resistance depends on the physical dimensions also, nature of the material also. Okay. Whereas resistivity do not depend on physical dimensions, it only depends on the nature of the material. But tau is interrelated with temperature. So where temperature changes means rho changes, automatically resistance also changes. So next is fourth point. Conductivity. Sigma is equals to 1 by the reciprocal of this. It is nothing but equal to n e square tau by m. This one, only formula they will ask you. What is the conductivity formula in terms of m? Only formula. They may ask for the conductivity, important. The derivation of the conductivity in terms of m means you have to take all the steps. Only ohms law in terms of m means after that only you take. Conductivity they ask after that, up to this point. And only formula also important for us. Sigma equal to n e square tau by m. And in this result of R resistance R depends on physical dimensions. L comma A minus temperature. Temperature directly you don't find the expression, indirectly you get that relaxation time. Temperature, comma, nature of material. Here nature of the material in the sense tau and T amounts. Tau depends on the time under the gap between the atoms automatically present and also effect on the temperatures. Nature of material. Whereas resistivity, this rho and sigma do not depend on the physical dimensions. Conductivity, one is interrelated to the other anyway. Do not, or else it depends. Depends only on temperature. Only on temperature, comma, nature of material. That means n and because m and e, electron mass and charges cannot be changed; they are fixed always. So remaining variable possibility is n and tau. So metal with conductivity. Conductivity is high if n is more, and if the temperature increases, tau decreases, so conductivity decreases, resistivity increases. Free electron density. Is constant for given material, nature of material. These are the extra points in effects you are taking. Derivations is only after this. These are all the extra points will be required for one of those also. Depends only on given nature of material. So this rho is proportional, inversely proportional to n. If n increases, real density increases, conductivity increases, but resistivity decreases. If n increases, then rho decrease, comma, sigma increase, because rho is proportional to the inversely proportional to n and sigma directly proportional to n for tau constants, resistive constants. So if you take the materials, this point is very important one. Among the given materials, silver has the maximum number of n. So silver has maximum value of n compared to other conductors, compared to other materials. Okay, so therefore silver is the best conductor. Is the best conductor of electricity. Of course, it is also best conductor of heat also, because heat transmission, but we have the three methods of the transmission of the heat: conduction, convection, and radiation. Conduction, vibration of molecules in the solid state, compressed, highly compressed liquids and gases. Convection, movement of the molecules or atoms. Here, movement of the electrons can move and can pass the heat energy also. So silver is the best conductor of heat also, best conductor of electricity. Right now we are discussing only electricity related, other point I will discuss anything. So they are asked to increasing or decreasing order of the conductivity. So we have is N silver is greater than N aluminum is greater than N copper. Next is N copper greater than N aluminum. So we take generally decreasing order of the conductivity. Best conductor is silver. Next best conductor is nothing but copper. Next best conductor is aluminum. These three conductors are generally used for connection purpose, electric purpose. Decreasing order of conductivity. Reverse is resistivity or increasing order of resistivity is first is silver, copper and aluminum. For the connection purpose, we can prefer silver, but silver is costly, so not generally used. Next we use is copper. So electrical wire connection we use copper. But if you want to use a long distance current connections, like electricity connection taken from the electric power stations, mega power plant, nuclear power plant, thermal power plants, hundreds of kilometer distance you take the connections, then copper again costly for us. So and also harnesses means reacts with the surrounding atmosphere, humidity, etc. So what is preferred is next is aluminum is preferred. Pure aluminum again is easily tarnishes, but what they use is indalium is used. Mixed alloy of aluminum is preferred, but aluminum is easily flexible, brittle also. Next is but aluminum is preferred of the large thickness, more thickness is preferred. Aluminum wires are used for electric wires. Okay, silver we cannot use them, it costly. And the second thing is people will take other wires. And order it is important for competitive exams also. Order, and we may be mentioning in terms of the resistivity. This data I will give you here, it's not necessary to remember, don't remember this. Just know the value powers only. Okay, and silver has is a resistivity value. Very low value of the resistivity is for silver. Low value of resistivity is high value of the conductivity, is reverse. And order you have to know for the conductors. Conductors, this resistivity value is the order of 10 to the power of -8. Power is negative. -8, -6, -7, like that. Minus power means what? 0.000 like that. Rho is very less means conductivity is small. Good conductivity. So they will give you the value and you just check up on this value. If this value is 10 to the power of -8 like that means it is a good conductor. They will give you the value and they will ask you whether it is insulator or conductor generally. So insulator water value resistivity is very high for the insulators. Insulators like you have water 10 to the power of 5, glass 10 to the power of 14 plus 14, powers 14. Quartz, it's a crystalline form of the silicon. One type of crystalline form of silicon is quartz. It's 10 to the power of 16. Like 10 to the power of 16 or 10 to the power of 10 for positive values. More than 10 to the power of 5 like that are there, they are called as insulators. So by seeing only this power value, plus is there means supposed to be insulators, minus power is there means conductors. Okay. Next is in between we have the material called as semiconductors. Semiconductors are nothing but the fourth group elements. In the periodic table, fourth group elements are called as semiconductors. Semi means half. They have the properties in between of the conductors. These are the conductors. They have the properties between the conductors and insulators. At low temperature close to absolute zero, the semiconductors behave like insulators. They behave like insulators. No conductivity will be there. But at high temperature, room temperature, high temperature, they behave like conductors. So in this carbon, we exclude carbon in the case. Why? Because carbon are available in electronic forms, different electronic forms. Carbon as a graphite, that means we got as a pencil lead. In the pencil we use now, that is pencil lead. Carbon as a graphite is a good conductor of electricity. You should never touch it with pencil electric box, okay? You will get the shock possibilities there. Can pass easily. Even black coal carbon, that is actual carbon. That also good conductor of electricity. Next is same carbon available as a tetrahedral structure. If it is forming as a crystalline form, we will call it as a diamond. Diamond is a good insulator. Diamond is an insulator. Diamond is an insulator. Okay, but that means what? Carbon, even at room temperature also, it can be a good conductor also, it can be insulator. So we are not going to discuss about the carbon. Generally we use semiconductor name means we talk about germanium and silicon in crystalline form. That too in crystalline form. In the crystalline, not in amorphous form. Crystalline form is particular order of the element of the atoms will be there. That time only they will show the specific property. At low temperature they behave like insulators. the intermediate properties between that are the instructors and the conductors. Okay, these values, this is going to be 4, we can take it as a 4.6 10 to the power of minus 1, 10 to the power of minus 1. This is going to get written as a 2.3 10 to the power of minus 3 plus 3, minus 1 plus 3. This is going to be written 10 to the power of minus 1. Okay, so this minus 5 and minus 1 like that minus plus 3, these values are related to semiconductors, but you will not be asked for the semiconductors. Same, they will ask you for the powers for the resistivity and insulators. Okay, so comparing this resistivity for the silver, copper and aluminum, or resistivity of silver is less than resistivity of copper, less than resistivity of aluminum. Conductivity reverses. Conductivity of silver is more than conductivity of copper is more than conductivity of aluminum. Now these points, this last point, this order is important to us, and the reason for that is only related to N. Okay. If the temperature changes, then effect is totally. Temperature, how it is affected, we are going to discuss again later. Separately, effect of temperature on the resistivity, resistivity and conductivity, etc. Based on that relationship, later we discuss because the papers are many equations. Next, we will discuss is mobility. This is not important for one mark question. It is the ratio of drift magnitude of the drift velocity, magnitudes of drift velocity and electric fields. Drift velocity and electric fields. It is a ratio of magnitude of drift velocity and electric field of light. Automatically, drift velocity means inside the conductor. Mobility. So, it is the Vd by E. Magnitude what you are taking is supposed to be positive. Vd by E is a relationship. Definition, they may ask you. Formula, problems proposed also. Next is units important for this. Definition units is very important. Vd by E is nothing but equal to drift velocity by electric fields. Vd equal to minus EE by M into tau is drift velocity. Of electrons is electric field. Tau is relaxation point. That is time interval between successive collisions of electron with the atoms is charge of electron.